Thank you very much. What I'm going to do in the next half an hour is I'm actually going to give you the pointy end of 12 years' work, in excess of 180 sort of trials that we've done and 69 odd farms that we've been working on. And just to set the scene, resistance screen done by ARI in 2011, the data is just about to be released, is that 84% of 96 paddocks randomly sampled had SU, Group B resistance, 76% had 2,4-D resistance, and 49% had Group F resistance. So resistance in WA is statewide, and it is a very, very real issue. So what I want to do is just give you some background to what's going on, because the radish plant has absolutely unbelievably awesome genetics and biology. So with the biology of it, because we have dormancy and we get multiple germinations over a season, is that genetics that we create 10 years ago, 9 years ago, 8 years ago, we'll be living with it today. So you actually get a complex mix of genetics that you're dealing with. Now in 2009, Mike Jackson presented some data at the WA Crop Updates, and that data was based on work done in a number of years previous, where we started to talk about what we call multiple resistance. And the complexities in multiple resistance is part of the reason why we've got all these issues. And there's two forms of multiple resistance. So we have what we call unstacked multiple resistance. So this is an example of an unstacked population. We've got resistance to the Group I, we've got resistance to Group F. When we mix them, we actually get complete control. So that's an important aspect to understand. In a sec, I'll give you an example of what we call stacked resistance. Where we have unstacked resistance, what you find is this is Paragon at 375 mil. So primarily it's a product similar to Tigrex, Group F and Group I. And as you can see, at that 3/4 rate, you get a massive range of data or results in there. When you go to the full label rate, it tightens up. Now in Western Australia, bromoxynil is just about a standard product that goes into just about every tank mix. So that's why growers are now spending an additional $9 per hectare because of the use of a bromoxynil. And if you look at what bromoxynil does, it'll take this 3/4 rate variation and it tightens the whole thing up. It almost gives it the same sort of result as the full rate. And when you get this full rate of F and I chemistry and add bromoxynil to it, you get complete control. So those treatments on the right, about 5 or 6 years ago when we were having to do that, they were costing between sort of $32 and $34 per hectare. So now that's actually come back. Now if you look at that same concept and you introduce stacked resistance, you actually get a third set of genetics sitting in there, and you have plants that actually have both F and I resistance. And this is the complexity in the issue that we're dealing with. So this is a really important concept, or not concept, but aspect to understand, so that when you get stacked resistance, the treatments along the bottom are exactly the same. The scaling is slightly different here, but when you get stacked resistance and you add Fi and bromoxynil Group C, what do you notice? You can't get 100% control. And what I'm going to show you in these populations, the amount of money that we have to spend is $40 to $60 per hectare because of that stacked resistance. So understanding this multiple resistance, is it unstacked, is it stacked, is very, very important. Now we've generated a massive amount of data over 12 years. What we did was we sat down because there were some trends that were starting to emerge. And what we're actually seeing is that there's 5 stages in the genetic development of resistance within radish. So the first stage, the populations are susceptible to all the chemistry. The second stage is that there's no overt resistance. But it's the sort of thing when growers come to you and they say, my esters are working better than my amines, I sprayed a little bit later, it was a little bigger, took a long time to die. They're seeing all those sorts of issues in the field. And what it was telling us is that there's a shift in the tolerance of that chemistry. To contrast that, when you look at stage 3 genetics, is that primarily our Group B chemistries shot. We get individual resistances to I and to F. When we mix them, they work. So this is like the unstacked population. It's that first Venn diagram when there's no shadowing in the middle. When we go and use our 3/4 rate F, I and C, full rate, we still get complete control. So it just gives us more robustness. To contrast that and to take that evolution another step further is we've got stage 4 genetics. And the significant thing about stage 4 genetics is that you still have individual I, individual F, but you actually get this stacking in the middle. The consequences of that is that this 3/4 rate F, I and C type chemistry starts to break. You have to use that full label rate of that chemistry, okay? This is where those dollars sort of start to come in, and you can't avoid it. The 5th stage is where we end up with very, very high levels of stacking, and when we throw the checkbook and full rates of F, I and C, we can't actually guarantee money. And what I'm going to show you in a minute is the cost of controlling those paddocks is up close to sort of $60 per hectare, and it's not negotiable. There's no other way that you can control that radish without spending that money. So there's these clearly defined sort of stages of resistance development appearing. So what I want to do is just give you an example of stage 5, 4 and 3, and what we're actually doing in the paddock. So I'll give you an example of a stage 5 population. So what we do when we screen these populations is we basically split the trial into 3 parts. So we do a lot of dose response screening, we look at the individual post-emergent options that growers have, and then we do sequential spraying. So now, probably 85 to 90% of all paddocks in WA with radish in get 2 sprays. The reason for that is because we need to take out subsequent germinations because of the seed bank and the germinations that come later, plus also to control those plants that survive the first spray. So this is an example from Morriwar, so you can sort of see the radish there. Some of these we're getting a bit of size up. And just to walk you through the dose response screen here is in the Group B. Primarily we've done 1 times the rate, 4 times the rate. So we've got no control with 4 times the rate of Ally, Spinnaker, Eclipse. We put Brodel in there as a Group F screen, so that's 2 times the rate, and this is 2 times the rate of S to 680. So that's the results from our screen. Nothing worked. When we go to this part 2 of the trial and we look at all the post-emergent options that the growers have, we've got LVE, Agritone or MCPA and Monza. The reason that we've got survivors there is because we've got B and I stacking. With Minder, which is like Jaguar type chemistry, F and C, the reason we've got survivors there is because of the F component. We've got products down here like Ecopar and Affinity, which is Group G. The reason that they don't work is because the phenoxy component doesn't work, and they must have an effective phenoxy component to work. What you do notice is that the Precept has done a pretty good job, just hasn't quite got there because of the phenoxy component. And in this trial, just through sheer numbers and some of these radish being a little bit bigger, the velocity didn't quite get there. So you can see this is a population where only the Group H chemistry is effective. No other modes of action will work effectively in this population. I've touched on the reasons why we do the sequential spray and why it's become standard practice in the West. All this trial work, what we've done as the first spray is we put everything in at full label rate. And what we've done is we've got our modes of action here, so these are the first sprays. At the top you can see our second sprays. So these second sprays generally go out when the crop's at about 3.0, 3.1. So we're doing it at an absolute optimum time, and that's generally about 3 to 5 weeks after that first spray. And what you can see is we can actually build just about all modes of action into it. So we can build up and look at what works and what doesn't. So at this Moral War site, where we had F resistance, I resistance, B resistance, this is where we've put out our full rate of flight. That's the result 21 days later, 50% control. If you made that recommendation in the paddock, would you be happy with it? So to show you the data from that, and just to walk you through these tables because they're a little bit busy, primarily we got 5% control here. When we followed with the ester, we got 92. So these treatments in the yellow here did not achieve 100% control. The treatments in the blue is where we got complete control. Now, if we take into account the first resistance screen that we did, and the phenoxy didn't work at all, stand alone, are we going to do that as a second spray? No. So that's why that's in the red. These treatments here, because of the Group F issues, are we likely to do these as a first spray? Probably not, because they didn't perform very well. I showed you the photo of what the flight did, or the FI&C. It didn't cut it, but we could follow it with velocity ester and do that. But because the first control was really, really poor, you're unlikely to do it. This paddock, they are the only options. And what we're very, very concerned with, and a lot of discussion going on now with these stage 5 paddocks, is that essentially these paddocks are getting 2 hits of H. In some paddocks they're actually getting 3 hits. In some paddocks they're actually getting followed with glyphosate. So that's the thing to look forward to when it all turns turtle. So the value in working with these extreme populations is you know where you're going. At Carnamah, this is a stage 4 population, just to bring it back and probably make it more real for the eastern states, is that you can see the radish that we're dealing with there. So at this site, the biggest of these guys were 10 centimetres. The treatments here are exactly the same as the stage 5 population I showed you, but essentially what I want to show you is that we've got resistance to SU, IMI, SA. This is Group F, so this is picolinophen that's in Paragon and Flight. This is diflufenicin, like what's in Jaguar and Tigrex, Minder. So we've got a low level of F resistance, but it's there. And you can see that we've got a very, very high level of resistance to phenoxy, because that's 2 times the label rate on 10 centimetre plants. Now, again, I don't want to spend a lot of time on these treatments. The treatment list is exactly the same as the previous one. But what you do notice is that we're starting to get a bit better control here because of the F components working. The flight, or the FI&C, is working quite good because of the level of resistances are lower. You can see our velocity performing very, very good, as it should. And then we've got eco-par and affinity, the Group Gs, because the phenoxy's no good. Then, if you jump a step and take all that into consideration, what's the sequencing you need to be doing in this population? Because of the I resistance, you're not going to do that there. Because of the F and these just two modes of action struggling, you're not going to be working there. This treatment here first worked quite well, so we can follow it with a velocity, or we can follow it with a velocity ester or H, I and C. Essentially, this paddock is $47 to $52. And what the grower did in this paddock, because he knew what was going on, he spent $52. So if you've got stage 4 populations, that's your spend, and it's not negotiable. You can't control it any other way. We can do this here, but we don't recommend it, and we're trying to avoid it at all costs because we've got 2 hits of H. So what we're trying to do is introduce as much chemistry in there as possible, and in these populations where I doesn't work, that H is very, very important as a second. Just a snapshot of a population at Una. Get some background here, did all the same screening. This population had indications of all that was low levels of B, just a fraction of F resistance, and just a fraction of I resistance. And when you work that data through and look at what worked, every treatment in that trial, in the sequential part of the trial, worked. Because of the lower degree of resistances, that stacking wasn't there. So this paddock, essentially, we can get control down to $21, right up to $59. The benefit or the positive when you don't have those high degrees of resistances, you actually get lots more, you get a lot more options to what you can use to control. You've got chemistry that's still alive that you can use. So as you break the degree of resistances down, the control gets better and better. So if you summarise all that and try and bring it together, if you've got stage 1, primarily you've got every mode of action available. And as these stages increase, we have no stacking, you can actually see what your dollar spend is. In stage 1 and 2, because you have no stacking and phenoxy still works, potentially your dollar spend could be like $14 to sort of $20. You'll see that I've put cost of a second spray in here at 7. When we first started doing sequential spray, our second spray was 2,4-D, and it's a full rate of 2,4-D. And again, what we're doing is we're cleaning up those survivors. And whilst I've put them in red, best management practice suggests that you need to be doing that second spray. So the attitude now of WA growers is they do not want to see a single radish plant in a paddock. 10 years ago and further back, they were quite happy to live with a plant here, plant there, plant somewhere else. Those plants that were there, they were the resistant genetic ones that kept building, and that's created all the problems because of the awesome biology of the plant. And as you can see, as we build, these second sprays and first sprays just really, really start to hurt you. And those pricings that are there, basically they're not negotiable. So what the conclusion is that we're actually really starting to see these paddocks segregate themselves out. The thing about this subject is that it's very, very big. There's a lot involved. But what we've got our guys doing, our growers are doing, is that every product that goes out is at full label rate. They do not cut rates. Second spray is a standard second spray. It's just standard practice. All our growers now, or most of our growers, are doing some sort of seed set management. So they're burning windrows, they're chaff carts, in extreme cases, the moldboard ploughing. They're looking at rotations. The other thing that's really, really got big is with soil testing. and we weren't doing so much seed testing, but now we're testing seed. And what we're doing is actually collecting those survivors, or the seed from those surviving plants, and we're sending them away. The challenge that we've got now with seed testing, now that we understand the significance and the importance of this stacked genetics that we have, is that we're having to talk to the seed testers to develop a test to test for that stacking, so that then you can make a judgment. So whilst we're challenging the academics, they're actually moving with us. So there's a lot of positive and a lot of benefit that's sort of flowing from it. And as I say, you must have this attitude of no survivors, because the more that you work with radish and the more you understand is that those survivors, they are the resistant genetics that are going to sort of hurt you. And what we know now, depending upon what happens on farm, is we can move from stage 3 to 4 in, say, an 8 to 10 year period. And if you make a mistake in stage 4, you'll hit stage 5 within an 8 to 10 year period. So you actually need to get the whole package right. In the proceedings there's a really, really extensive paper there, which what I've tried to do is give you the complete background and all the knowledge that we have, into the subject of what's going on. So I'll leave it at that if there's any questions from the floor. How do growers and advisors identify which stage they're at in the paddock? As I say, like, resistance testing now is becoming fairly standard, so it costs about sort of $90 to $100 a mode of action. So it's sort of a bit like soil testing, where it's becoming very, very commonplace. So that's how they're doing it. This stages of radish development, this is like brand new that we're actually presenting. That's why we're sort of going to you guys and in WA at the crop updates and talking to everybody about these stages. So generally the areas where we have really bad radish and the growers are spending, that $40, $50, $60, they're aware of it. They probably haven't just said, hey, that's a stage 4 or stage 5, and I think this information here will actually help them sort of segregate it out into what sort of stage. Really good question. The reason that I wanted to sort of start with a stage 5 population to show what they're actually having to do is that I've worked in a lot of those paddocks, and whilst you go there you think, what are we going to do? This is a basket case, we can't farm it. But the good thing is that those growers recognise they've got an issue and they say, hey, we need to fix it. So one of the worst populations we've worked in, the guy did 2 years fallow. He's grown wheat for the last 2 years. He's grown it with 3 lots of velocity in crop. So there's residue issues and all sorts of other things that go on. He's got a weed it machine. So in the fallow phase, he's taking them out. And then if he's got any odd plants, he's actually spraying it out with glyphosate. He'll kill the crop in those areas. We went back last year to try and work in one of those paddocks, and we cannot get enough radish there to do work on. So it's not all doom and gloom. You can actually fix it. The really interesting thing is, or the difficult thing is, that we can talk about this with growers and they'll say, geez, I'm not spending even to do a two spray and sort of sit in here and say, you should be spending $27. They go, no, I'm spending 15. That's the hard communication piece, if you know what I mean. So that's why I think the resistance testing and saying, hey, you're sitting here is where it's sort of where you're at. But once the guys accept and understand, they go with you the whole time. Our guys do not question spending the money because they have to, but ultimately they're trying to fix paddocks and run it down. The question is, I talked about 5 stages. Stage 6 could be lose pyrosulfatol. What have you got? How many Group H sprays before we build resistance? I don't know, and maybe that's a question to throw to Bayer, but I know Ari actually working with pyrosulfatol to look at that. Our attitude is, at the end of the season, if you have no survivors, you have no seed set, you shouldn't be putting any resistance genetics back into it, if you know what I mean. So that paddock I was saying, the stage 5 we worked at, the reason that farmer does what he does at the end, if he's got any survivors and he just nukes the crop or those patches because they sort of live in families, you know, where the genetic's been created, he's saying I'm having no seed set. Even though I've had 3 velocities, I'm having no seed set. So I think you can avert it, but if you're a farmer, if you've got a farmer who's a bit casual and says, well, I've done, you know, I'm a Group H and I've got an odd survivor, I'm not going to worry about it, those are the guys that are going to be in trouble, because it'll come. Radish is an outcrossing species and you can move genetics within it really quick. Triazine is the maternal trait which doesn't move as quick. No, the reason I put that in, and there's a note in the proceedings, is there's been some consultants recommending it. It's off-label, and the reason that I put the Group G in with the phenoxy is to show that it's not doing anything at all. And what these guys are trying to do, they don't fully understand, is they're trying to play catch-up and put other modes of action in there. Once you lose that phenoxy component, Group Gs are gone out the window. What we're trying to do in the southern parts of the state where the resistance is not so bad and we still have phenoxies that work, is we're trying to use Group Gs as a broader, you know, so we've got some more hits of different modes of action. In all these paddocks here that I've shown you, 3, 4 and 5, Group Gs don't work. So that was in there for another exercise. But basically it causes a lot of crop effect, almost kills it, and it actually makes the weed control worse in some cases. But well spotted. Good question, Bill. When we start to run into problems of control, and part of the reason why we did was the old thought was we'll wait till the radish gets big, we'll get another germination out, we'll spray it. So they're actually spraying the crop when it was 5 or 6 leaf, and we had, you know, radish that big. And what we found is when they get tolerant or there's a shift and they're a little bit resistant, you can't kill them, but when they're that big, you can kill them. So now the whole attitude of one spray later, try and get them all in one hit, is gone. So our guys now, that crop's at 2 leaf and they start spraying, and they start spraying with a product like Minder or Jaguar, like F and C. Crop gets to 3 leaf and then it's F, I and C. The first spray goes out really early and it actually builds time. And then the second spray generally falls about 3031. We're not waiting until later, if you know what I mean. So that whole timing window has come forward. So the second spray is not a salvage, it's blocked in there. In the trial work that I did, most of my second sprays were 3 to 4 weeks after my first spray.